Okay, let's take a look at number 1 on page 250. Determine the phase shift and vertical displacement with respect to y equals sine x for each function. Sketch a graph of each function. Well, we're given a function, y equals sine x minus 50 degrees plus 3, and I'm just going to write the sinusoidal function y equals a sine b x minus c plus d. Okay, so if we take a look, our variables are a is 1, b is 1, c is 50 degrees, and d is 3. Okay, so the phase shift is 50 degrees, 50 units to the right, and the vertical displacement is 3 units up. So I'm just going to draw, note the sine function always starts at 0, 0. So for y equals sine x, we have 0, 0. And I'll just write up my key points. 90 degrees, it's 1. And here we have 180. So here's the graph of the sinusoidal function, y equals sine x. Whoops. Okay, so if we take a look at this, essentially what we're doing is we have a phase shift of 3 up. So if we take a look, let's take a look at this point. We're going to go 1, 2, 3 up. And 45 degrees or 50 degrees to the right. So it's 3 up and 50 degrees to the right. Okay, B. Okay, y equals sine x plus pi. Y, I'm going to rewrite it, equals a sine b x minus c plus d. Okay, easy to figure out what the parameters are now. A equals 1, b equals 1, c equals negative pi, d equals 0. Okay, so the phase shift is pi units to the left, pi units left, and no vertical displacement. Okay, to sketch the graph, you would use the amplitude, again of 1 because A is 1, and the period is 2 pi over B. B is 1, so the period is 2 pi. So that's what you would use to sketch it. There's no vertical or horizontal stretch. D. Okay, here we have another function, y equals a sine b x minus c plus d. So for c, we have A equals 1, B equals 1, C equals negative 2 pi over 3, and D equals 5. So the phase shift is 2 pi over 3 units left, and the vertical displacement is 5 units up. Okay, to sketch, the amplitude is 1, the period is 2 pi over b, or 2 pi over 1, and there is no vertical or horizontal stretch. Okay, here we have y equals 2 sine x plus 50 degrees minus 10. Well, y equals a sine b x minus c plus d. So we have a is 2, b is 1, c is negative 50 degrees, and d is minus 10. So the phase shift is 50 degrees to the left, 50 degrees left, and vertical displacement is 10 units down. So to sketch the graph, we have an amplitude of A is 2, and the period is 360 over 1, or 360 degrees. And there is no vertical or horizontal stretch. The period will stay at 360. E. Here we have y equals negative 3, 6x plus 30 degrees minus 3. So we're going to rewrite this as y equals negative 3 sine 6 x plus 5 degrees minus 3. Okay, so we have a equals negative 3, b equals 6, c equals negative 5, d equals negative 3. So the phase shift is 5 degrees left, and the vertical displacement is 3 units down. So to sketch the graph, we use the amplitude of 3, period of 60 degrees is 360 over 6, which is B, or 60 degrees. And there is no vertical or horizontal stretch. We're going to also reflect the graph in the x-axis because A is negative. Okay, F. Y equals 3 sine 1/2 x minus pi over 4. So what we have here is A is 3, B is 1/2, C equals pi over 4, and D equals -10. So the phase shift is pi over 4 units right, and vertical displacement is 10 units down. To sketch the graph, also use the amplitude of 3, and the period is 2 pi over 1/2, or 4 pi. And there is no vertical stretch or horizontal stretch. The period will stay as 4 pi.